after discussion on the values, now we are taking the trigonometric table with you, discussing the trigonometric table with you, and here we are taking the angle A, right? And here the trigonometric ratios: sine, cos, tan, cosec, sec, and cot, right? And here we are we have the angles which we have already discussed how we can obtain their values. So 0, sine 0 will be 0, and sine 30, sine 30 will be 1 upon 2. And what is the value of sine 45? 1 upon root 2. What is the value of sine 60? That is root 3 upon 2. And sine 90 is 1. Right? We have calculated already. And then cos A. What is the value of cos A? Just take this table in reverse order. That is 1. And this is root 3 upon 2. And that is 1 upon root 2. Both are same. And that is 1 upon 2 and 0. 0 here, right? We are reversing the order of this table in cos. 1, root 3 upon 2, 1 by root 2, 1 upon 2, and 0, right? After that, tangent A. Tangent A, basically we have the formula for tangent, that is sine A upon cos A. So we can divide both these values, sine A upon cos A, that is 0 upon 1 becomes 0. This upon this becomes 1 upon root 3. And this upon this becomes 1. Root 3 upon 2 becomes root 3. 1 upon this becomes undefined. Undefined, or you can take this symbol for infinity, that is undefined, right? After that, cosec A. What is cosec A? Cosec A is nothing but it is a reciprocal of sine A. Cosec A is nothing but it is a reciprocal of sine A. So we can take cosec A as reciprocal of 0, that is again undefined. Reciprocal of 1 upon 2, that is 2. Reciprocal of this is root 2. Similar way, 2 upon root 3, and reciprocal of 1 is itself. And secant A, again you can reverse it. 1, 2 upon root 3, that is root 2, 2, and infinity. We can reverse this table to get the value of secant A. And when you cot A is the reciprocal of tan A. So we can take the reciprocal of tan A, that is reciprocal of 0 is undefined, that is root 3. 1 reciprocal is 1, that is 1 upon root 3. Undefined reciprocal is 0, right? So in this way, we can obtain the value of cot A also. So this is a table which is associated with the acute angles. We are taking the measure of the angles from 0 to 90 degree. So these all are the acute angles and we can obtain their values. I have already discussed in my video that how you can obtain these values, and now how you can learn these values. So basically, main thing is how you can learn the value of sine A. After that, when you learn this value, then you can reverse these all to get the cos A, dividing both to get the tangent A, and tangent A reciprocal is cot A, same, and cosec A is the reciprocal of sine A, and secant A is the reciprocal of cos A. So in this way, we can learn this whole table. And now, how you can apply this table on the questions, right? Suppose we need the value of this expression. So for solving this expression, we have these all values. So first of all, see sine 30. What is the value of sine 30? Sine 30 is 1 upon 2. In front of sine and 30, we can obtain this value 1 upon 2. So substitute its value 1 upon 2. Then what is tangent 45? Tangent 45 in front of tangent and 45 we have 1. So this value becomes 1. Minus cosec 60. In front of cosec and 60 degree we have 2 upon root 3. So its value is 2 upon root 3. In this way, secant of 30 degree. What is secant of 30 degree? In front of secant 30 degree, that is 2 upon root 3. Plus cos 60. What is cos 60? Cos 60 is here, 1 upon 2. Cot 45 is 1. And now solve these two values. 1 upon 2 plus 1 becomes 3 upon 2 minus 2 upon root 3. And here 1 by 2 plus 1, that is again this plus 3 upon 2. Now we can take the LCM 2 root 3. That becomes 3 root 3 minus 4. Similarly, we can take the LCM 2 root 3 and multiplying this 4, 3 root 3. So we get, this will cancel, and 3 root 3 minus 4 and 4 plus 3 root 3. But we know in the denominator, we cannot leave as irrational numbers, right? So for irrational numbers, we can rationalizing it. to convert into the rational one. So rationalize it. 4 plus 3 root 3 and 4 minus 3 root 3 and 4 minus 3 root 3. That becomes minus of 4 minus 3 root 3 whole square, and in the denominator we have 16 4 square minus 3 root 3 whole square. That becomes 27, and we can obtain its value finally by eliminating it, and you can find out its value easily, right? The main thing is you have to substitute these values which are given in the table, and when you substitute these all values, then solve it, and keep in your mind that irrational numbers cannot live in the denominator. So you have to solve it. If irrational number is there, so first of all you rationalizing it, then obtain the answer, which will be the correct answer for the given problem. This problem is also a good problem. Sine of a plus b is root 3 and tangent of a plus b is root 3 and tangent of a minus b is 1 upon root 3, and a plus b lying between 0 and 90 means a plus b is also an acute angle, and find the value of a and b. Then how we can find out the solution for this problem? The tangent of a plus b is equals to root 3. It implies that a plus b will be, where is the tangent? Root 3. Root 3 in front of root 3 we have tangent and 60 degree. So a plus b will be 60 degree. And also tangent of a minus b is equals to 1 upon root 3. In this table, where is 1 upon root 3? This one. The tangent a at 30 is 1 upon root 3. So tangent of a minus b is 1 upon root 3 implies that a minus b is equals to 30 degree. Now we have these two equations 1 and 2. Solving these two equations, adding 1 and 2. If we add these two equations, then a plus b plus a minus b becomes 60 plus 30 degree. That becomes 90 degree. You can cancel out this 2a, and a becomes 45 degree. 2a is 90 degrees, so a becomes 45 degree. And whenever you add subtracting a 1 and 2, so we obtain a plus b minus a plus b is equals to 60 minus 30. ये cancel हो जाएगा आपका, that is 2b is equals to 30 degree. In this way, we can obtain this value, that is b is 15 degree. So we can evaluate the value of tangent a as well as we can evaluate the value of a and b easily. Yes, our next topic is trigonometric ratios of complementary angles, right? Complementary angles. Suppose we have this triangle ABC, and this angle is A, and this angle is C. We know about it. And what is the value of sine A? We know that the value of sine A is perpendicular, that is BC, upon hypotenuse, that is AC. And what is the value of cos C? Basically, A and C, sum of these two angles is 90 degree. So A and C are the complementary angles, right? A and C are the complementary angles. So cos C becomes, for cos C, this will be the base BC upon hypotenuse, that is AC. So cos C is equals to sine A, simply because sine A, for sine A, we have this perpendicular. With respect to C, this is a base. So both formulas are shows the value same. So sine A is equals to cos C. But since A plus B is equals to 90 degree, A plus C is equals to 90 degree, then C becomes 90 minus A. Obviously, we can write sine A is equals to cos of 90 minus A. So in this way, we can take this formula, cos of 90 minus A is equals to sine A. So these two are called the complement. Cos is called complement of sine, right? Cos is called complement of sine because cos of 90 minus A becomes sine of A. By using this property, we have already discussed that sine of 30 is equals to cos of 60. Sine of 60 is equals to cos of 30. So by using this property, we can check easily that why these two values are equal, and simply sine of 45 is equal to cos of 90 minus 45, that becomes 45. So sine 45 is equal to cos of 45. That is the trigonometric ratios of the complementary angles. In the same way, we can show that sine of 90 minus A will be cos A, and cos of 90 minus A will be sin A, and tangent of 90 minus A will be cot A, and cot of 90 minus A is tangent A, and secant of 90 minus A is cosecant A, and cosecant of 90 minus A is equal to secant A. And these are the 6 trigonometric ratios which are complement of each other, like sine is complement of cos, or cos is complement of sine. Tangent, cotangent is complement of tangent, and cosecant is complement of secant. So these two formulas are associated with each other. These two formulas are associated with each other, and last one is sine and cos are also associated with each other by using the complement angle formations, right? So how we can apply this concept on the questions? Suppose we have this problem, sine of 18 upon cos of 72. First of all, check what is the sum of these two angles, 18 and 72. What is the sum of these two angles? That is 90 degree. Obviously, if their sum is 90 degree, then we can use these formulas with the associated problem. So sine of 18 upon cos of 72. So we can write it as sine of 18, and cos of 72 can take it as 90 minus 18. There is no problem because 72 can expressed as 90 minus 18. What will happen? 90 minus theta. Cos of 90 minus theta. Cos of 90 minus a becomes sine a. So at the place of a, we have 18 degree. So sine of 18 upon this can be written as sine of 18. Both will cancel and its value becomes 1. In this way, we can solve. We are interested to find out the value of cosec of 31 minus secant of 59. Again, we have the same concern, 31 and 59. What is the sum of these two angles? That is 90. So we can apply these formulas. So cosec of, that is our solution. We have to convert any one of them. You can convert the secant into cosecant or cosecant into secant, any one. That is secant of 90 minus 31, and secant of 90 minus 31 is cosecant A. So we can write it as cosecant of 31. That becomes 0. In this way, we can convert, either you have to convert the cosecant into secant or secant into cosecant. So secant 59 can express as secant of 90 minus 31. Then this 31 at the place of A. So secant of 90 minus A becomes cosecant A. So that becomes cosecant of 31. Both will cancel and value becomes 0. So in this way, we can solve. Suppose we are taking one more interesting problem. Tangent of 2a is cot of a minus 18, and find a if 2a is an acute angle. If 2a is an acute angle, then find the value of a. Right? So tangent of 2a is equals to cot of a minus 18. If 2a is acute angle, so we can replace it by 90 minus 2a. If any trigonometric equation is there, then we have to eliminate cot or tan by taking both are same. Either you have to convert this tangent into cot or this cot into tangent. So we are converting this tangent into cot. So tangent of A can written as cot of 90 minus A. So at the place of A, we have 2A. So cot of 90 minus 2A is equals to cot of A minus 18. Now cot of A is equals to cot of B whenever A is equals to B. So 90 minus 2A is equals to A minus 18. Now separate the values containing the variables, that is 3A, and this becomes 90 plus 18, that is A plus 2A, that is 3A, and this is 108 degree, that is 3A, and value of A is 108 degree upon 3, that is 36 degrees. So A is 36. In this way, we can solve the problem, right? After this, we will move towards the quadrant system and the trigonometric identities and the problem based on those trigonometric identities one by one, and meet you soon in our next video with the trigonometric functions. Thank you.